Just a few seconds after leaving the ground, one of America's most secret and expensive strategic weapons suddenly lost control. The legendary B-2 Spirit stealth bomber had barely taken off before it turned into a pile of wreckage. This crash became the most expensive accident in the history of military aviation. On February 21, 2008, at Andersen Air Force Base in Guam, a U.S. Air Force B-2 Spirit bomber, serial number 89012, had just completed a military exercise in Guam. 4 B-2s participated in this exercise, and this aircraft was the last one scheduled to return home. Because the base had just received a large number of fighters and weapons, hangar space was extremely limited. According to safety regulations, each B-2 must be parked inside a closed hangar to avoid being detected by foreign satellites and to protect its sensitive sensors from the weather. However, the first 3 B-2s had already filled the hangars, so this one had to be parked temporarily outdoors. This was far from ideal. The B-2 is not only a top-secret weapon, but also extremely sensitive. Its body is covered with hundreds of sensors and advanced stealth coatings. Even the slightest variation caused by rain, humidity, or temperature can seriously affect its performance. As a strategic bomber capable of penetrating any modern air defense system, the B-2 Spirit can carry up to 18 tons of weapons and has a range of over 11,000 kilometers. In the 21st century, it has been known as the Ghost of the Sky, a symbol of America's global strike power. On that day, the bomber was scheduled to fly from Guam back to Whiteman Air Force Base in the United States. For the past 4 months, it had been carrying out rotational bomber missions under the Pacific Air Force's command. The planned flight was expected to last 16.2 hours, covering about 11,900 kilometers, and required 2 mid-air refuelings. The original takeoff was scheduled for February 22, 2008, but when the crew was preparing to depart, bad weather at the destination forced a 24-hour delay. This meant the aircraft had to stay outside even longer. Although the B-2 can fly in bad weather, it is extremely sensitive to moisture when parked, which makes outdoor storage highly risky. At 8 a.m. on February 23, 2008, a team of U.S. Air Force engineers began a comprehensive inspection of the B-2 bomber to prepare it for the upcoming flight. Because the mission had been delayed for 24 hours, the operations deputy commander, squadron leader, mission coordinator, and flight lead held a meeting during the crew's pre-flight preparations to review the weather conditions at the destination and decide whether the mission should proceed. The aircraft commander for this mission was Colonel Justin, a highly experienced pilot with over 2,330 flight hours, 336 of which were on the B-2 bomber. He commanded the 14th Training Squadron, responsible for training both U.S. and Allied pilots. Colonel Justin held 6 bachelor's degrees and 2 master's degrees, all in military and aviation-related fields. His co-pilot, Major Ryan Lynn, had 2,660 hours of flight time, including 279 hours in the B-2. He was a career military aviator who began his career in a fighter squadron, flying aircraft such as the F-16. After rigorous selection, he was transferred to the B-2 unit, an elite group open only to the Air Force's top pilots. Both pilots carefully reviewed the aircraft's maintenance records, packed their personal gear, and loaded the mission equipment. Since the aircraft was returning to the U.S., personnel also loaded additional spare equipment into the rear cargo bay. At 9:15 a.m. local time, the crew started the engines and powered up the systems. Everything appeared normal. No faults were detected. The pilots then proceeded through the pre-flight safety checklist, while maintenance technicians updated the aircraft's weight and balance data to account for the extra equipment. At 9:29 a.m., following the flight manual, the pilot switched the flight control system into maintenance mode. At that moment, a warning message appeared on the display, indicating that the aircraft required calibration of its startup data, parameters that are critical for safe flight. The captain immediately called the flight systems technicians to come and assist with the issue. At 9:34 a.m., a technician arrived on the tarmac to calibrate the aircraft's system data on site. This was an essential step to ensure that the plane's sensors, especially the pitot tubes and static ports, were functioning accurately after the previous night's rainfall. Once calibration was complete, the B-2 began taxiing toward runway 06, preparing for takeoff as planned. At 10:29 a.m. local time, the pilot activated the pitot-static heating system, which warms the sensors that measure airspeed and altitude, preventing them from icing up. The captain confirmed that the system appeared to be working normally. Under normal circumstances, when the PSH off, pitot-static heater off message disappears from the display, it indicates that the heating system has been successfully activated. However, this time there was a serious discrepancy. The terrain data showed that the actual elevation of the runway was 546 feet, but the aircraft's altimeter indicated 682 feet, a difference of 136 feet. Because there were no visible elevation markers at the runway, this error went unnoticed before takeoff. At 10:30 a.m., the captain pushed the throttles to maximum power and began the takeoff procedure. About 10 seconds later, he released the brakes and the aircraft started accelerating along runway 06. A previous B-2 had already taken off safely, using a takeoff roll of 5,825 feet and reaching a liftoff speed of about 145 to 147 knots, approximately 270 kilometers per hour, the standard safe takeoff speed for this aircraft type. However, Major Ryan Lynn, who was piloting this B-2, rotated at only 4,375 feet, 1,450 feet earlier than the previous aircraft. At that moment, the actual speed was only 244 to 248 kilometers per hour, but the cockpit airspeed indicator showed 267 to 270 kilometers per hour, about 12 knots higher than reality. This error led the crew to believe that the aircraft had already reached safe takeoff speed, so they pulled up too early. As a result, the lift was insufficient, and the bomber could not maintain stable flight. About 19 seconds after brake release, an unexpected warning appeared. The master caution light illuminated, and the flight control system issued alerts on the display. A warning appeared, indicating air data problems, including key parameters such as airspeed, altitude, and angle of attack. The co-pilot immediately acknowledged and analyzed these warnings. However, just 6 seconds later, the flight control system automatically cleared the warnings, meaning the computer had determined that the aircraft was still in a normal state. All alerts disappeared from the screen, leading the pilots to believe that the issue had been resolved. At 10:30 a.m., the nose wheel lifted off the ground, marking the official start of the takeoff. Following standard procedures, the captain pulled back on the control stick to maintain a steady climb angle and speed. But the moment the main landing gear left the runway, a serious problem occurred. The onboard computer began calculating the angle of attack, the angle between the airflow and the aircraft's nose. Because the sensor data was incorrect, the system calculated an excessively large angle, mistakenly believing that the nose was dropping sharply. To correct this perceived error, the flight control system automatically commanded the nose to pitch up. As a result, the aircraft suddenly pitched upward too steeply and too fast. Its nose angle reached 30 degrees within seconds. At such a low altitude during the initial climb, this was extremely dangerous. Since the B-2 had not yet reached a safe flying speed, the abrupt and excessive nose-up motion caused a sharp increase in G-force, reaching 1.6 times the force of gravity on both the aircraft and crew. Worse followed. At 10:30 a.m., all airspeed data suddenly disappeared. The sensors stopped transmitting information about airspeed, altitude, and angle of attack to the flight control system. With this data lost, the system was forced to switch into backup mode. However, without accurate readings of angle of attack, airspeed, or lateral drift, the flight control system became unreliable and the aircraft's stability dropped sharply. The captain fought to regain control, but it was too late. The bomber had already lost stability completely. At 9:29 a.m.,
Following the training manual procedures, the captain switched the flight control system into maintenance mode. At that moment, they noticed a warning message appear on the display, indicating that the aircraft required calibration of its startup data, parameters that are critical to flight operations. The captain immediately called for a flight control technician to assist. At 9:34 a.m., a technician arrived at the parking ramp and began on-site calibration of the system data. This was an essential step to ensure that the aircraft's sensors, especially the pitot tubes and static ports, could still function accurately after the previous night's rainfall. Once calibration was completed, the B-2 taxied toward runway 06, preparing for takeoff as scheduled. At 10:29 a.m. local time, the captain activated the pitot-static heating system, which heats the sensors responsible for measuring airspeed and altitude to prevent them from icing. The captain confirmed that the system appeared to be functioning normally. Under normal conditions,
When the PS off, pitot-static heater off indication disappears from the display, it means the heating system has successfully engaged. However, at this time, a serious discrepancy appeared. Terrain data showed that the actual elevation of the runway was 546 feet, but the aircraft's altimeter displayed 682 feet, a difference of 136 feet. Since there were no elevation markers near the runway, this error went unnoticed before takeoff. At 10:30 a.m., the captain pushed the throttles to maximum power and began the takeoff procedure. About 10 seconds later, he released the brakes, and the bomber started accelerating along runway 06. A previous B-2 had already taken off safely, using a takeoff roll of about 5,825 feet and achieving a liftoff speed of 145 to 147 knots, around 270 kilometers an hour, the standard safe takeoff speed for this aircraft type. However, Major Ryan Lynn, who was piloting this B-2, lifted off at just 4,375 feet down the runway, 1,450 feet shorter than the previous aircraft. At that moment, the actual airspeed was only 244 to 248 kilometers per hour, while the cockpit airspeed indicator showed 267 to 270 kilometers per hour, a difference of about 12 knots, 22 kilometers per hour. This discrepancy led the crew to believe the aircraft had already reached safe takeoff speed, prompting them to rotate too early. As a result, the aircraft did not generate enough lift to sustain stable flight. Roughly 19 seconds after releasing the brakes, a critical malfunction occurred. The master warning light illuminated, and the flight control system displayed alerts indicating problems with the air data, including airspeed, altitude, and angle of attack, all crucial flight parameters. The co-pilot immediately acknowledged and began analyzing the warnings. However, just 6 seconds later, the flight control computer automatically cleared the alerts, interpreting the data as being within normal limits. All warnings disappeared from the screens, leading the pilots to believe the issue had been resolved. At 10:30 a.m., the nose wheel lifted off, marking the start on the takeoff phase. Following standard procedures, the captain gently pulled back on the control stick, attempting to maintain a steady climb angle and speed. But the moment the main landing gear left the ground, a serious problem occurred. The onboard computer began calculating the angle of attack, the angle between the aircraft's nose and the direction of the airflow. However, due to faulty sensor data, the system calculated an excessively large negative value, mistakenly believing that the nose was pitching sharply downward. To correct this perceived error, the flight control system automatically issued a command to raise the nose abruptly. As a result, the aircraft pitched up far too rapidly and too steeply, with its nose angle reaching 30 degrees almost instantly. At such a low altitude during the initial climb, this was extremely dangerous. Since the B-2 had not yet reached safe flying speed, this sudden and violent nose-up movement caused the aircraft and crew to experience an overload of 1.6 G, 1.6 times the force of gravity. Worse was yet to come. At 10:30 a.m., all airspeed data suddenly disappeared. The sensors stopped transmitting information about speed, altitude, and angle of attack to the flight control system. In this situation, the system was forced to switch into backup mode. But without accurate readings for angle of attack, airspeed, or lateral deviation, the flight control system became unreliable, and the aircraft's stability dropped sharply. The captain fought to regain control, but failed. The aircraft had already lost all aerodynamic stability.